In the frigid twilight beneath Jupiter's watchful gaze lies Europa, a distant orb that, at first glance, seems nothing more than a frozen wasteland. Its surface gleams brighter than the moon that circles our own planet, etched with endless brownish streaks and scars. Not a single mountain or deep crater disturbs its serene icy plains, as if the tranquil facade conceals something extraordinary below. Could Europa be guarding the greatest secret in our solar system? Numerous spacecraft have turned their instruments toward Europa. Since the earliest images captured by Voyager in 1979, each encounter has shown a world with a remarkably young face. Unlike our own moon, whose surface is battered and scarred by countless impacts, Europa reveals a landscape as level as a vast frozen sea. One of the Voyager scientists once marveled at the startling lack of ancient craters. Clearly, some process is erasing the past, resurfacing the moon, and smoothing the scars with silent persistence. The ice itself appears to shift and move, as if steered by unseen forces. Might a secret ocean beneath the shell be responsible? In this documentary, we will explore the riddles and signs hidden across this faraway moon. Fractured ice, a concealed ocean, enigmatic sources of energy. All these clues draw us ever closer to a single, burning question. Could life find refuge beneath this frozen lid? Let us begin by noting that Europa's icy exterior is anything but featureless. In fact, it is scored with wandering cracks and tangled patterns. Some of these lines, stretching for more than 1,000 miles, slice across the moon's surface like fractures in an enormous frozen lake. Known as lineae, these features often run parallel or crisscross, weaving a planet-wide network. When scientists examined images from Voyager and Galileo, they found that opposite sides of certain cracks fit together like puzzle fragments, as though the crust had torn and shifted, allowing darker material to bubble up and fill the rifts. Broken shards of ice are scattered across the surface, reshuffled into new positions, much like the drifting and freezing of ice flows in Earth's polar waters. In some regions, chaos dominates. Areas the size of entire cities appear jumbled and newly frozen, where blocks of ice tilt, rotate, and lie amid lumpy terrain and refrozen slush. Appropriately, scientists refer to this landscape as chaos, for it looks like ice partly melted from below, then refrozen into a chaotic assembly of layers. These disorderly blocks, giant frozen bergs, suggest that warmth or liquid from below has forced its way upward. Elsewhere, dome-like swells rise above the surface, while pits reveal spots where ice has sunk inward. Such landforms hint at an active, living shell, perhaps rising and falling atop a secret ocean. This begs the question, what causes Europa's ice to move as if it possesses a life of its own? We find echoes of this activity on our own planet. In the Antarctic, ice sheets drift, crack, and pile up atop the ocean's surface. On Europa, a similar dance may unfold, not powered by wind or tides, but by inner forces. Clues of hidden activity are everywhere. Smooth plains with few craters indicate that something is constantly renewing the surface. Could it be cryovolcanism, with briny water oozing upward and freezing, or the gentle bobbing of the ice shell above a liquid layer? By the time the 1990s arrived, mounting evidence led scientists to a remarkable conclusion. Beneath Europa's ice might lie an ocean. What began as mere hypothesis gained strength in the closing years of the 20th century. NASA's Galileo craft circling Jupiter in the 1990s was equipped to peer into Europa's mysteries. Each close pass brought more signs of an unseen sea. Galileo weighed Europa's gravity and discovered that its density and inertia matched a moon with a thick ice shell above a rocky core. But Galileo also recorded something peculiar about Europa's magnetic field. As the spacecraft swept past, Jupiter's immense magnetism was oddly disturbed near the moon. The most convincing explanation? Europa was generating its own induced magnetic field, created by electrical currents in a vast hidden conductor beneath its crust. Based on what scientists have uncovered about the moon's makeup, it seems highly probable that an immense ocean of briny water acts as the chief conductor beneath its surface. Observations from cameras and data from spectrometers have likewise reinforced the existence of this ocean. Images captured by Galileo revealed surface markings that only made logical sense if the outer shell of ice could move independently from the inner layers. For instance, the longest fissures on the surface did not correspond with the locations expected had the crust been tightly bound to the moon's core. Instead, their placement made perfect sense if the icy shell could glide over a liquid layer below. Moreover, the two most prominent impact scars on Europa display circular ring patterns as though a massive asteroid had punctured the icy exterior and struck a softer underlying layer. Every one of these clues pointed in the same direction. Below the frozen shell lies a layer of liquid water. Yet, a pressing mystery remained. How could a moon so distant from the sun still host liquid water? The answer became clear after studying Europa'S relationship with Jupiter. Locked in a perpetual gravitational struggle with Jupiter and its fellow moons, Europa'S interior is stretched and compressed by formidable tidal forces as it completes each orbit. This tug-of-war causes the icy surface to flex by as much as 30 yards. The continual bending produces friction within the moon, much like warming your palms by rubbing them together. This friction supplies a steady influx of energy, preventing the inner ocean from solidifying. In essence, Jupiter's gravitational embrace serves as Europa'S internal furnace. Calculations reveal that the heat generated by these tides is more than enough to keep a vast subterranean ocean in a liquid state beneath the frosty exterior. Estimates suggest this icy shell measures from 9 to 15 miles thick, while the hidden ocean beneath may plunge to depths approaching 60 miles. This concealed sea likely contains over twice the volume of all the oceans on Earth combined. Today, scientists widely accept the presence of this subsurface ocean on Europa, often referring to it as an ocean world. The prevailing view holds that a floating crust of ice rests atop a salty sea, which in turn overlays a rocky seabed and a metallic core. Such an ocean paves the way for fascinating geology and possibly even life. Europa'S ice is not a static barrier, but a restless, shifting lid atop a secret ocean, continually warmed by Jupiter's immense gravitational power. If there truly is a shadowy ocean beneath Europa'S frozen surface, the next question arises: what energy could support it, especially if life is present? Sunlight cannot penetrate this abyss, blocked by miles of ice, leaving the waters in unending darkness. Still, all known life needs energy to survive. On Earth, nearly every ecosystem on the surface depends on light from the sun. Yet deep beneath the waves, another world flourishes, unaffected by sunlight. At hydrothermal vents on the ocean floor, strange and wondrous creatures thrive by harnessing chemical energy. Here, superheated water loaded with minerals surges from the vents, and specialized microbes convert these chemicals into sustenance. Towering black smokers are crowded with tube worms, mollusks, and blind crabs, a vibrant community sustained by the planet's own inner warmth. Could Europa conceal similar hydrothermal havens? Many planetary scientists think this is not only possible, but probable. Beneath the moon's ocean, a rocky mantle and core are believed to exist. This rocky layer is continually flexed and warmed by tidal forces, just as the icy crust is, which could spark geologic activity on the seafloor. If certain regions of Europa'S ocean bed are sufficiently heated, water meeting the hot rock might erupt as hydrothermal vents, just as happens along Earth's mid-ocean ridges. Recent computer simulations indicate that even low-temperature hydrothermal vents could persist for billions of years on the shadowy ocean floors of moons such as Europa. Put simply, even without the blazing heart of a volcano, internal warmth may drive vent systems that endure across geologic eras. These vents would supply both heat and a banquet of chemicals, the precise combination needed for simple life to flourish. They emit hydrogen-rich fluids and nutrients, forging chemical gradients that microbes can convert into energy. Such places are regarded as potential birthplaces for life on the young Earth. Unlike the dramatic black smokers that depend on fierce volcanic activity, Europa may be home to milder, warmer vents. On Earth, these quieter vents actually move much more water and can endure for much longer stretches of time. The crucial idea is this: Europa's ocean floor does not have to be a volcanic wasteland. The thought stirs the imagination. Might living things lurk in the pitch-black depths beneath Europa's icy shell? The heart of the matter is simple. When seeking life beyond our planet, scientists have long compiled a list of the most fascinating locations. Mars, with its long-lost rivers and ancient lakes, once appeared to be the obvious candidate. Saturn's moon Titan has its own lakes filled with methane and a thick, hazy atmosphere. Intriguing, yet perhaps too frigid and chemically bizarre for Earth-like biology. In recent times, attention has gradually shifted away from Mars and towards Europa, and for very good reasons. Europa offers a rare combination of habitability, water, energy, and the proper chemistry. First comes water, the universal solvent essential for life as we know it, and Europa has it in abundance. This moon is the most water-rich body known in our solar system. Beneath its icy exterior lies an ocean that may contain twice as much liquid water as all of Earth's seas combined. Second, energy. Every organism needs a source of power. Europa's thick ice blocks sunlight, but as we have learned, tidal forces create internal heat, and hydrothermal vents may deliver chemical energy. Additionally, Jupiter's harsh radiation plays a curious dual role. It batters the ice, splitting molecules apart and creating oxidants such as oxygen and hydrogen peroxide. These oxidants could slowly filter downward, nourishing hidden microbes in the darkness. According to recent calculations, Europa's surface generates around 1,000 tons of oxygen every day through radiation-driven chemistry, enough to sustain 1 million people for an entire day. Third, chemistry. For life to emerge, elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur must be present. Europa formed from the same abundant ingredients as other worlds, and over time, comets and asteroids likely delivered extra organic materials. Research indicates that its underground ocean is probably salty and packed with minerals. Spectrometers have found compounds on the crust that give clues to its makeup. For instance, ordinary table salt, sodium chloride, appears on certain areas, giving the ice a yellowish shade and hinting that Europa's ocean may have a similar saltiness to Earth's seas. Recently, the James Webb Space Telescope discovered carbon dioxide ice in younger terrains, strong evidence that carbon from the ocean is reaching the surface. All the necessary chemical components for life, water, organics, and more, seem to be present. Now let us compare Europa to its rivals. Mars is now a cold wasteland with scarce liquid water. Enceladus, a small Saturnian moon, holds a subsurface ocean and even spews out geysers. Enceladus ranks high among candidates for habitability, but its ocean is much smaller, and life might find it harder to arise in such a tiny world. Titan has an inner ocean and a wealth of organic molecules atop its crust, but its lakes of hydrocarbons are a very strange arena for life. Ganymede and Callisto, Jupiter's other large moons, likely possess deep oceans as well, but their ice layers are so thick and inactive that nutrients may not easily circulate. Europa, by contrast, seems to hit the sweet spot. A vast and enduring ocean, active geology moving nutrients around, and a reliable energy source. Kurt Niebuhr, chief scientist at NASA for exploration of the outer planets, has said, quote, "Europa is the most promising place to look for life beyond Earth right now. Nowhere else in the solar system fulfills the conditions for habitability quite as well. So, we suspect that a deep ocean lies hidden below. We talk of energy and nutrients, and we let our minds wander toward the possibility of alien life swimming in that faraway sea. Yet a question lingers. How far might such life have truly evolved?" Up to this point, our theories have been restrained, limiting ourselves to the idea of microbes or perhaps the simplest forms of life. But the mind inevitably drifts toward bolder speculation. What if humanity is not the first intelligent presence to emerge in this solar system? Suppose there exists a thriving biosphere beneath the frozen shell of Europa, perhaps even an entire civilization hidden away in the perpetual darkness of its vast sunless seas. This notion has enchanted science fiction authors for decades, yet even as a mere thought experiment, it continues to fascinate and unsettle us. Consider the possibilities. The ocean beneath Europa's ice has remained stable for billions of years, offering evolution ample time to explore unimaginable pathways. In endless night, creatures might have evolved heightened senses, sensitive to electric currents or the faintest shifts in pressure. Is it conceivable that complex beings, perhaps akin to fish or squid, inhabit those lightless waters? Could intelligence have blossomed in such an environment? Might they have established a society beneath this frozen ceiling, completely hidden from the rest of existence? If so, their only glimpse of light could be the dim blue glow of the sun filtered through miles of ice, forever deprived of the sight of stars.
Still, these questions remain unanswered until we can peer beneath the surface. Our next challenge is to get closer, to sense the breadth of those fissures and sample the spray from that concealed ocean. Encouragingly, we are making real progress. In the past few years, Europa has offered unmistakable clues about its secret sea, brief glimpses from beneath the ice. Astronomers directed the Hubble Space Telescope toward Europa and were rewarded with a remarkable discovery: faint jets of vapor ascending from the moon's surface. In the year 2012, Hubble detected ultraviolet glows near Europa's south pole, a sign that molecules were being expelled and split into hydrogen and oxygen. The most straightforward interpretation, according to Lawrence Roth, lead scientist at the Southwest Research Institute in San Antonio, was, and I quote, that water vapor erupted from jets on Europa's surface. If this is accurate, Europa would become only the second moon ever known, after Enceladus, to actively eject its subterranean ocean into space. These so-called breathing cracks behave much like geysers or icy volcanoes, according to Hubble's data, which suggest the plumes appear at intervals. Curiously, these eruptions were observed when Europa was at its greatest distance from Jupiter, not its nearest. This observation fits a model where tidal forces flex Europa's crust. When the moon is stretched to its limit, cracks open and the built-up pressure releases, launching vapor skyward. As Europa swings closer to Jupiter and the tidal tension eases, the fissures snap shut. In effect, Europa seems to breathe in and out with each orbit. The plumes are thought to shoot as high as 120 miles, forming graceful veils of water that soon rain back down. Europa's strong gravity makes sure that most of this water never escapes into space. Not long afterward, more evidence arrived. In the year 2018, scientists took a fresh look at archived data from NASA's Galileo probe and realized that Galileo probably flew right through one of these plumes in 1997 entirely by accident. For roughly 3 minutes during a close approach, the spacecraft's sensors recorded abrupt shifts, magnetic fields twisted, and the count of charged particles spiked, matching what one would expect from passing through a cloud of ionized water. This discovery bolstered the case that Europa does, on occasion, vent water into the void. Today, we possess Hubble's observations from afar and Galileo's direct measurements. Each offers a different piece of the puzzle, yet both point to the same conclusion. So, what exactly are these plumes? Picture fissures in the polar ice acting as vents. When underground pressure mounts, perhaps from a pocket of water or slush, the cracks burst open, releasing vapor and possibly shards of ice. In essence, Europa is experiencing icy eruptions, a frozen version of volcanic activity. These revelations electrified the scientific world. Each plume offers a direct portal from the hidden ocean to the surface, raising a tantalizing question. What else escapes from those cracks? Is it only vapor or something far more intriguing? While we know that water vapor is the main component, could these plumes also deliver other ingredients from Europa's concealed ocean? On the distant world Enceladus, one of Saturn's many moons, incredible geysers shoot out water mixed with salts, organic chemicals, and even tiny mineral grains directly from the seabed below. This raises an intriguing question. Could the plumes erupting from Europa also be laced with salts or organic molecules transported from its hidden ocean? The Hubble Space Telescope's instruments, as powerful as they are, lacked the sensitivity to spot intricate chemicals within the moon's faint vapor. Observations confirmed only the unmistakable presence of water. Still, scientists strongly believe that if we could gather and study the full spectrum of material from these spectacular eruptions, we might uncover much more than water alone. There may be minuscule particles of salt or clay, simple organic compounds, or perhaps even cells, if they exist at all. The possibility that Europa'S vapor conceals more than just plain water provides compelling motivation to send new spacecraft to investigate. These geyser-like fissures are, in essence, nature's way of handing out free samples from the ocean concealed beneath Europa'S icy shell. All that remains is for a spacecraft to pass through and collect the clues waiting in the mist. If living creatures do reside in Europa'S ocean, then the plumes might carry chemical fingerprints of their existence. But what might those traces look like? They could appear as certain organic molecules, perhaps intricate hydrocarbons, or uncommon mixtures of gases, such as an unexpected abundance of methane together with hydrogen. This combination was seen on Enceladus and is interpreted by some researchers as a possible indicator of microbial life. Even the simple detection of the building blocks of life within Europa'S plumes would be a monumental discovery. So what have we learned for certain so far? Europa'S surface is strewn with mysterious substances. The Galileo spacecraft spectrometers measured chemicals like sulfur dioxide, most likely created from sulfur or Io's unusual internal chemistry, and hydrogen peroxide, which forms when ice meets harsh radiation. The surface is not merely plain ice, it contains other materials, possibly salts or organic compounds. The trailing side of Europa, constantly battered by charged particles, is noticeably reddish-brown. Scientists propose that the unknown molecules responsible for this patchy red hue could be oxidized salts or complex organics, either pulled from the ocean below or shaped by energetic radiation. In the year 2023, the James Webb Space Telescope spotted carbon dioxide focused in a patch of chaotic terrain on Europa. This is persuasive evidence that the carbon dioxide originated from the restless ocean beneath. This discovery also clearly establishes that carbon, a vital element for life, exists within Europa'S ocean and indeed rises up to the surface. But what about organic compounds in particular? On Enceladus, when NASA's Cassini spacecraft flew through the icy plumes, it detected a variety of organic chemicals, some rather complex, as well as dihydrogen, a sign of hydrothermal activity. We have not yet achieved such detailed measurements for Europa. Nevertheless, if similar activity is at work there, we might find simple organic molecules such as methane, methanol, formaldehyde, or even amino acids and other intricate compounds frozen within the ejected ice. A particularly exciting idea is that any microbes inhabiting Europa'S ocean might be instantly frozen into ice as the plume water bursts into the cold vacuum and solidifies. These tiny organisms, or the remains of their cells, could then be preserved on the surface. In this way, Europa'S plumes may be scattering evidence of life, should it exist, across the moon's icy crust. A future lander or flyby probe might one day uncover these secrets. Scientists also suggest that Europa'S unique geology could actively ferry material from the ocean, not only by way of erupting plumes, but also through the continual creation of new ice in chaotic regions. If living things are present, their biochemistry might leave behind traces, such as special fatty molecules, lipids from cellular membranes, that become trapped in salt as water freezes. Recent research even hints that some kinds of lipid molecules could survive this journey and be detectable with the right spacecraft instruments. For now, the first unmistakable evidence of life on Europa remains just out of reach. No one has yet found proof of living organisms, but we have discovered that the conditions needed for life, water, the right chemistry, and sources of energy are all present. We have discovered intriguing compounds such as peroxide, carbon dioxide, and possibly ordinary salt, which hint at the presence of an ocean much like our own on Earth. These revelations keep our optimism alive. Astrobiologists have put forward a range of potential ecological models. It is conceivable that mats of microorganisms blanket the warm stones scattered along the sea floor, drawing nourishment from chemicals released by hydrothermal vents. Slightly more advanced organisms, akin to brine shrimp or tube worms on Earth, might graze upon these microbial communities. Remarkably, we may soon be able to put these ideas to the test. Humanity has already dispatched its next envoys to Jupiter's domain, determined to unveil the secrets of this enigmatic ocean world firsthand. 2 significant missions are poised to make history. NASA's Europa Clipper and the European Space Agency's Jupiter Icy Moons Explorer, affectionately called JUICE, are on their way. Europa Clipper stands as the first mission dedicated solely to Europa. Its robotic probe is engineered to assess whether this moon could harbor life. Launched on October 14, 2024, Clipper will journey for several years, aiming to arrive at Jupiter around the year 2030. Rather than orbiting Europa itself, the spacecraft will circle Jupiter and conduct roughly 50 close flybys of Europa. During each approach, it will soar over different regions of the moon, sometimes passing as near as 15 miles above the surface, close enough to sample material ejected by any plumes. On board is a formidable array of 9 scientific instruments, the most sophisticated ever sent to the distant reaches of our solar system. These devices are purpose-built to remotely map the ice, probe the ocean beneath, and scrutinize the moon's chemical composition. High-resolution cameras, part of the Europa imaging system, will record the moon's ridges, fissures, and tumultuous areas in breathtaking detail, revealing features as small as a few yards across and creating stereo images of the icy terrain. A thermal imager will seek out warm patches on the surface, possibly pinpointing locations where water lies close beneath or where recent geological activity has left the ice heated. An ultraviolet spectrograph will examine Europa's exceedingly thin atmosphere and any gases rising from plumes, identifying elements and molecules through their unique spectral fingerprints. Crucially, Europa Clipper is equipped with specialized tools to investigate the ice itself. The radar sounder, known as Reason, will transmit radio waves down into the crust and listen for returning echoes. This will unveil the structure of the ice shell, highlight distinct layers, identify pockets of brine or liquid water, and potentially even glimpse the top of the subsurface ocean if the ice proves thin enough. An array of magnetometers, teamed with a plasma instrument, will meticulously study the moon's induced magnetic field. Through this, scientists hope to confirm the ocean's existence and establish its salinity and depth. Minute changes in the magnetic data as Europa moves through Jupiter's magnetic domain will reveal just how conductive and thus how salty the ocean is, as well as how deep the conductive layer sits below the surface. Another tool, the Gravity Radio Science Experiment, will monitor subtle variations in the spacecraft's path during flybys to deduce how Europa's internal mass is distributed, essentially unlocking clues about the thickness of its icy shell and the density of its ocean. Clipper also operates as a mobile chemistry laboratory. On board, the mass spectrometer known as MassSpex is engineered to directly examine particles and gases swirling near Europa. When the spacecraft glides through a plume or a faint mist of molecules knocked loose by radiation, MassSpex will gather these atoms and molecules, separate them by mass, and identify their nature, whether water vapor, carbon dioxide, sulfur compounds, organic molecules, or something else entirely. Alongside MassSpex, the Surface Dust Analyzer, or SUDA, will snare minuscule grains of ice and dust expelled from the moon. When each microscopic particle strikes the detector, it vaporizes, revealing its internal composition. SUDA's unique talent lies in its ability to identify salts and complex molecules encased within these grains. Should a plume or surface impact propel a fragment of oceanic material into the space above Europa, Suda and Maspex together can decipher its chemical blueprint, determining whether it is laden with sodium chloride, rich in organic matter, or contains some wholly unexpected ingredients.
In short, the Europa Clipper mission offers humanity a unique opportunity to sample Europa's hidden ocean without ever boring through its frozen crust. The information it collects will unravel crucial mysteries. How deep is the icy shell, and does it shift or move? Using radar and high-resolution imaging, scientists will be able to determine whether the ice is partially liquid and spot any fresh fissures or geysers. Is the subsurface ocean truly global, and what are its depth and salt content? Devices measuring the moon's gravity and magnetic fields will help build this understanding.
What materials cover the surface, and do any plumes shoot up from the interior? Sophisticated spectrometers will scour the surface for organic salts and hints of underwater chemistry. Are there active zones where ocean water and ice currently meet? By mapping surface temperatures and topography, the mission could reveal warm regions or jumbled landscapes, possibly created by upwelling water, just like the chaotic terrain that might sit atop rising plumes.
All of these findings will contribute to the biggest question of all. Could Europa's ocean support life? While Europa Clipper cannot directly detect living organisms, it will deliver the most thorough evaluation yet of the moon's habitability, perhaps even turning up indirect hints of life's presence.
Meanwhile, across the Atlantic Ocean, the European Space Agency has launched the JUICE mission, designed for an extensive survey of Jupiter's icy satellites. On April 14, 2023, JUICE began its 8-year voyage, with arrival set for 2031. Its chief destination is Ganymede, where it will ultimately orbit, but along the way, it will twice pass close to Europa. During these fleeting visits, JUICE will supplement Europa Clipper's findings, although it carries a different arsenal of scientific tools.
JUICE's equipment list boasts high-definition cameras, spectrometers, a laser altimeter, instruments for probing beneath the surface, magnetometers, and plasma analyzers, 10 tools in total, ready to investigate Jupiter's moons. As JUICE sweeps past Europa, it will capture intricate images of select areas at a resolution of mere dozens of yards, unveiling terrain never before seen. Its radar will examine the moon's crust at alternate frequencies to those of Clipper, possibly reaching other layers. Spectrometers on board will scrutinize the surface's makeup, perhaps confirming the presence of salts or organic molecules from a new vantage point. Instruments tuned to study charged particles and magnetic fields will explore the environment around Europa, verifying the moon's generated magnetic shield and maybe catching traces of plume material or plasma changes. The teamwork between these twin missions will create a layered, comprehensive investigation. By the middle of the 2030s, scientists expect to have a wealth of unprecedented new information. These ambitious missions lay the groundwork for even more daring explorations. Should Europa Clipper detect persuasive signs, for example, evidence that the ocean teems with organic chemicals or hints of biological activity, the next step could be to land on the moon itself. NASA has already imagined a Europa lander, which might drill a short way into the ice or gather fresh ejected samples for direct study. Looking further ahead, one could envision a probe melting its way through the ice to swim in the ocean below, or a robotic explorer venturing into the moon's shadowy depths. Over the coming decade, Europa will cease to be just a distant icy speck in the sky. It will transform into a world with mapped vistas and, maybe, a detailed list of what secrets its ocean holds. Bit by bit, the enigma of life beneath the ice will begin to yield to concrete evidence. Will we uncover simple organic molecules, complex chemistry, or even telltale traces of life? Or might we find an ocean overly salty or starved of oxygen, rendering it less fit for life than we hope? The journey to unmask the true nature of this ocean moon is underway, and the most thrilling revelations may be waiting just beyond the next fracture in the ice.